All right. Hey, everybody, and welcome to our next session. We are here with Matt Olmstead, who's going to be talking about group activities to help with understanding. Thank you so much for coming on, Matt. Take it away.
So thank you, Anthony. Thank you, everybody, for being here. So I'm a physics professor, and so I've been introducing the ideas of games in my classes at all different levels at the college level. I'm at a small liberal arts college in Northeast Pennsylvania. And so I just want to be clear, though, what I'm trying to do is I'm not trying to teach physics through this games, right? There are a lot of games that do this, right? Some of the things that I've thought about are things like probability. You could use this using magic. There are lots of ways to do that. Motion interactions. There's a new board came out that uses electricity. There's lots of different things there. That's not what I'm doing. So I'm hoping that these ideas I'm going to talk about, these games, are going to overlap, and there's some ideas you can use here. So I do use them to reiterate key ideas or strategies. So one thing in physics is it's really useful to draw pictures, right? A very nice picture will give you a lot of information. And this is something students really struggle with. It doesn't matter how good you can draw, but it matters that you can get the key information out. And it's also a really nice way to look at many of these topics from different ways. And I found that in doing this, I see lots of misconceptions and misunderstandings that I would never, ever see if we were just solving problems and going through a traditional way. So some of these things are like drawing pictures, looking at pictures, using word connections. One of the earlier in-person talks used several games I've used. I've used Werewolf, I use Medium. But so what I want to do is I'm going to go through 5 different games, right? We're going to give a very brief example of how to play, and then just give you an example and some ideas I've got from them. So the first game is Telestrations. This is basically telephone, where you whisper in somebody's ear and it goes around the circle and it goes back and forth. This has many different names. The commercial one is Telestrations. But the idea here, instead of just whispering words, is somebody writes a word down, then you pass it to the neighbor, they draw the picture. Next person looks at that new picture, writes the word back and forth. So what I've done is I've taken, instead of just a word, I write down a physics question. And then the students look at this physics question and they draw a picture for it. And then they're going to take that picture, pass it to somebody else who then has to write the question that corresponded to that picture. And then we're going to pass it one more time. And again, as I said earlier, in physics, I can look at this picture that they've drawn here, and I can tell you what the question is, right? I can answer the question and try to figure out what's going on with just a good picture. Okay. And so if I look at this, I can see, okay, somebody's got a ball. Maybe they're standing 5 meters above something. They're going to throw the ball 30 meters and it hits the ground. And this looks like, how fast did they throw the ball? So I go, and this was the question a student made from that picture. A person standing on a 5 meter high surface throws a ball, it lands 30 meters away. What is the velocity of the ball being thrown? And then this was the picture that somebody drew after that. So, right, it gets passed 3 times. I gave the first question. Somebody drew this first picture. They passed this to another student who said, this is the question that goes with that picture. And then here's the second picture another student draw. And if you look at these pictures look very similar. That's good, right? They're getting the right information down. Okay. So I'm going to go through another example. Okay. So this question is a little bit longer. Okay. And this is something I've tried. What if I give them a little bit more information, right? So you've got somebody who has some mass. They have now jet-powered skis. I tell them this thrust, right? How much force are on the skis and a coefficient of kinetic friction. And then the skis run out of fuel. What is their top speed? So again, the question is really looking for what is their speed. Here's the picture the student drew. Hey, it looks good so far. We've got maybe some skis. They've got rockets on them. This idea of how much thrust, how much force was applied to it. But if we look over here, there's a couple of funny things. Okay. They're not looking for, remember the question was, what is the top speed? This picture is looking for a distance. So there's a big disconnect there, right? Students always think physics is all about just knowing what equation to use. And it's really not that at all, right? It's about knowing what you're given and trying to figure out. And so here they're actually looking for the very wrong thing. Okay. And this is a very good way to illustrate this. And then there's something else here. it's a little particular, but this is not the frictional force I gave, it's something else. Yeah, I gave a coefficient of friction, so that's something different than the force. But if we look at the next question, the student correctly identified that was the coefficient of friction. So that's just another thing. After we do these questions, we discuss them, right? So we'll go through some pictures, we'll discuss them. And we can say, look, here you've got a couple big misconceptions. Now you're solving a different problem. Okay. And then I'm just going to put up, now a student took this new question, the woman, right? They have the same information here. She still weighs 78 kilograms, goes for 15 seconds. But notice this one, it didn't actually talk about which way she traveled. So the new picture from there has somebody going up instead. It's a very different question. But they are still looking for what is the distance traveled. Remember, that was not the initial question. That's the question they're looking for. Okay. So again, this was a physics specific example, right? And I've got ways I can change this. Instead of showing pictures, I could do equations. They should be able to do the same thing. You know, I've talked to people, this can be used, you know, in computer science, but I imagine there's lots of areas where you can say, let's draw something and go back and forth. I think this can be used in different ways. In physics, this just happens to work really, really nicely. Okay. So the next one I'm talking about is this idea of some sort of spectrum. Okay. So this game is called Wavelength, and you're really just you want some sort of spectrum. Okay. So the idea is you're going to have some sort of range. So the example I'm going to talk about first is just cold to hot. Okay. So let's say cold is on this side of this spectrum and hot is over here. One player is going to see this colored area here, and they want to say some sort of word that is going to make their team move this pointer over to here. Is that idea hopefully makes some sense? You've got some sort of spectrum. We're going to say cold to hot, but it could be, you know, fast to slow. It could really be anything. And one player looks at this and says, I want to get them to get something that's on this end of the spectrum. And then you're going to take this blue marker and cover it up. And people have made versions of this to work online during COVID, and they work really well as well. But here, so let's just say, for instance, I had this, so cold to hot. I know I want you to guess over here. I might think about it and say something like, okay, I want something hot, but not the hottest thing I can think of. So maybe I'd say the surface of the sun. Okay. So by saying the surface of the sun, we know there's hotter parts of the sun, right? So that might be over here, something very hot, but that means the sun's pretty hot. So somewhere over there. Okay. So another example would be like, if I said room temperature, well, that's a strange thing because, right, we like to think of room temperatures kind of in the middle. Okay. But it's also really cold compared to the sun, which is really cold compared to inside the sun. So there's just different things to think about. And so this leads to lots of discussion on there. And you don't exactly have to do this with spectrum. So like I tried one where I said, I want sinks on this side and floats on this side. Or sorry, it was floats over here on the left and sinks over here on the right. Okay. So again, something either sinks or it floats. It's not a both, right? It's not a spectrum. You can kind of say some things float better than others, some things sink faster than others. And that's what we're going for. But the student said iceberg. Right? I like to think an iceberg is kind of right in the middle. It's very close to neutrally buoyant. Okay. So I would put it here. But my student was actually doing it over here, where they're saying it's 90% of it is sinking. Right. So this leads to lots of discussions. It's like it's still floating, even though more of it's underwater. Right. So again, this brought out different things that we would never talk about. Right? I would never talk in my class and say 90% of it's sinking. We might say 90% of it is underwater. And those are just very different ideas. And again, this never even said it had to be in water. So there's just lots of ways to think about this. You know, I do fast to slow, big to small, massive to less massive, all sorts of things, but there's lots of other ideas you could use for your spectrum then. So these were two more, you know, visual ideas. This next one is using this game called Medium. And the way this works is really what I'm going for here is just trying to connect different ideas. Okay. So the other two we're looking at techniques we use, ways to think about things. Here's a way just to connect different ideas. So I use this in my senior seminar class where they've got all sorts of physics knowledge. And let's just try to connect some ideas. So the idea is I write 2 words up on the board, okay, pair students up in partners, and they're going to look at those words, and then I'm going to count to 3, and they're both trying to say a word that connects the two. And their goal is to say the same word. Okay? So they have 2 words. They want to come up with a 3rd word that connects these 2 ideas. That's the same word their partner comes up with. And so I want everybody to look at these 2 words, momentum and energy. I just want you to think about it for a couple seconds. Try to find a connecting word. Okay, so I'll give you 5 more seconds. Now you would tell your neighbor, you don't have a partner right now. But I did this in a physics conference with physics teachers a couple weeks ago from around the country. And they came up with words that are not what I came up with. When I made these 2 words on this slide, I said, this should be conservation, right? Conservation of momentum, conservation of energy. That's a very important topic in physics. Physics teachers came up with all sorts of different ideas, right? They're going distance, motion, all these different things. But then the way the game activity works is if you did not match, you take your 2 new words and you again try to come up with a connecting word. And you do that up to 3 times. So here I picked 2 words that are generally used in the introductory physics. But in my senior seminar, I picked words, all over. Some of them they learned their 2nd year, some of them they just learned their 4th year, and connect those ideas. And it leads to really neat things. And again, this is something I can see if you're trying to connect 2 different topics, right? Or bring connections from what you learned at the beginning of the semester, or when you're talking about one book to some other book. I think you could use these sorts of ideas there. And so here was a more physicsy example, right? So the 2 words are orthonormal and vector. But I just put this one up to show you that they did think about these answers are all reasonable things, right? They weren't going off the wall. They were saying, okay, here's some things that you probably should think of. And I think I had 12 people in this class when I did it last time. And so there were some that did match up. If not, these are all things that, again, could match up. Okay. So I've got 2 more games I want to talk about. This one is going to be a little more difficult to explain, and it's a team game. Right? So you've got 2 teams, and the idea is that there's going to be 6 cards out. So let me show you an example of 6 cards. One team is going to look at these 6 cards, and they're going to pick one of them to show a single player on the other team. Okay. So they pick one of those cards, and now they give that player a criteria. They give them one. And so maybe they would say here, name a cartoon character. So again, that player from the other team is looking at a single card, and they're going to name a cartoon character to try to make somebody pick it. So let's just say they handed me one over here, and I said Aladdin. Okay. So maybe I was thinking this one, right? There's a tiger. Aladdin has a tiger. Could be all sorts of different things. But the way this works is you kind of, again, you only gave that player a single card. So you might want to try to trick them a little bit. So the example I did in class was same cards, right? They had these cards. So they told the student they have to pick a bolded word in physics. And I define that as a word that would be reasonably bolded, some sort of definition. Okay. And here in pink, I just have some of the different examples of things I came up with. And I would give the team 2 of these, they would pick one. Okay. But so a student looks at a single one of these cards, and then they have to say a bolded definition word that is probably in some sort of physics textbook bolded. So the student said Doppler effect. If you're not familiar with the Doppler effect, this is why when the police car comes towards you, it goes, and goes away from you. It's right? The That's the Doppler effect. Things moving towards you are higher frequency, things moving away are lower frequency. Okay. So the students looked at this a lot, and they were stuck between these 2 words. Okay, the top left and the top center. Because Doppler effect does something called redshift and blue shift. That's this high frequencies and the low frequencies. Something moving away from you is redshifted, moving towards you is blue shifted. So they were looking at these 2. And they ended up picking one of them. And in doing this, they were said, okay, well, if this would have been the card he said, he should have said buoyant. If this was the card, maybe they would have said like non-Newtonian fluid. So they were thinking about better clues while they were trying to figure it out. But they came up here and they guessed this left one. And the actual answer was this top right one. And the student was, again, thinking this idea of red shift and blue shift, right? So red and blue. But in physics, it's when you're away from it is red and towards you is blue. So that's why the other students didn't like this one, right? But again, we're trying to connect these different ideas. And this is one they really like. So the last one I want to talk about, the last couple minutes, is the idea of Pictomania. I'm not going to explain this full game, but just know in this game, you're going to get points for correctly guessing what other people have drawn. You're going to get points for quickly guessing what they've other drawn. And you're all drawing at the same time, which means you're also going to get points for people correctly guessing what you've drawn, right? And so you want to be drawing this quickly, and you're also looking at everybody else. So the big thing about this is everybody's doing it at the same time, okay? And it works, you want groups of up to 6, right? So when I played it last time, I had 12. So again, I just worked two tables were playing at the same time. And so a student is drawing one of these 7 words. And you don't know which one, but they're from the 2 different groups. So one student's drawing one of these words. The other student is drawing another one. They might be drawing the same one or different, because again, I'm basically playing 2 games at the same time. But one thing to notice here is they've drawn very similar pictures. Okay, we've got 2 sorts of waves. It looks like we want to add them together and we get this bigger wave. And that's what it looks like they're doing here. So you might think by looking at these 2 pictures, they have the same word. Okay, they don't. Okay, they were given 2 very different words. One of them had constructive interference, which is the 2 waves adding together, but somebody had beat frequency. Okay, so even though their pictures look the same, they were thinking very different things. So in our discussions, it brought out all of these different ideas, right? So again, that's kind of the key of doing it this way, is we're really looking at these things in different ways. And I really like that. So what I have found makes a good game in this situation. You want to be something quick to understand. Hopefully you understood most of the games I just talked about. You don't want it to be too gamey, okay? If you have more time, that works. Most of these I did in 15, 20 minutes. The Pictomania one takes longer. I did that one about 60 minutes. But the other ones I can do in 5, 10 minutes. So we don't want it too gamey. In general, you want it to be something that you can do. Everybody's doing something at the same time, right? The wavelength game I showed you, there is one student who stands out. They're the one making the clue. And which you don't always want that, but that one had lots of neat things that they really liked about it. But again, your goal, I found it works better when everybody's doing something and you don't have one player standing out. Okay, so here are just some examples of what they liked, right? They saw these different connections. They saw all these different things, right? And again, the first ones I was showing the importance of diagrams and how to actually get stuff out of that. And I found that it does help them a little bit, right? Like, do I have data on, do these activities help them learn physics better or draw better pictures better? Well, I've looked at old exams before and after, and they are drawing better pictures, right? They're not drawing perfect pictures, but their pictures do have more details than if they just have like a ramp sliding down or a block sliding down a ramp. Most of them, about half them used to just draw a ramp with an angle indicated. Now they put more information on it. Okay. And so there's just some reference I've looked at, and some of these people I've been working with on some of these different activities, but that's where I want to stay.
Wonderful. Thank you so much, Matt. So again, as we mentioned in the past, if you have any questions for Matt about his work or his presentation, please post those in the Discord. That's the best place to post them and get answers for that. That's the end. We made it. Thank you everyone who attended all of our presentations, whether you were here at Gen Con, at Dread Day, whether you were online virtually, whether you're watching on Discord. Big special thanks and shout out to Jen, who's been running the Discord, communicating with everybody, keeping everything organized. Just amazing, especially like all 3 of us here, and then having just someone who can just keep all the pieces moving. It's been so awesome. But thank you again, everybody, for attending. I will be sending out recordings of everything from today. All 12 of our presentations should be out in the next 24 hours. Those will be sent to you by email. If you registered through the website, they will be posted on Discord otherwise. So everybody will have access to those, hopefully by the end of the day tomorrow, depending on how Zoom works. And yeah, if you have questions, concerns, just want to talk games, academics, anything, please hop on the Discord. It will keep running. We will be there. You can keep communicating and you will be the first to hear about all upcoming future events. This has been fantastic. It's been wonderful. And it's been just a pleasure to have you all with us, and to all of our presenters especially. Thank you so much for your time and your expertise over the last 4 hours. All right. Thank you, everybody, and have a great rest of your day.